Okay, so let's have a look at question 3. And in question 3, what we've been asked to calculate is this funny P symbol thing here. What this funny P symbol is saying to us, so in words what it's saying is the probability that this x thing is greater than 8, greater than or equal to 8. Now we're told something about this x. We're told that if we drew a histogram of it, it would look something like this. The probability that this x is going to take on a value between any two places is described by the area underneath a normal curve. In fact, it is in fact this normal curve here, because we're told it has a mean of 6 and a standard deviation of 2, and this is just the diagram of a normal curve that looks like that. So what we want to do is to figure out what is the probability that this x is greater than 8. So in other words, what we need to do is to figure out this area in here. We want to know what is this area in here. And because we just told greater than 8, well, how great is great? I mean, it could be anything. So we need to keep going. We need to keep going all the way out to like infinity. Forever that way. So we want the area between this 8, the curve, a point way out at infinity, and then along the x-axis. So we just need this area here. Now I just happen to remember that this area out here, this big long area out here, that's always going to be, no matter what the mean and standard deviation is, it's always going to be 0.023. So in this case, I can see straight away that the area that I'm interested in is going to be this 0.136 plus the 0.023. So I can actually write this down immediately. It's going to be 0.136 plus 0.023, which gives us 0.159. Now, if you don't know what these numbers are, then we can always figure that out in our calculators as well. So the way to figure out on your calculator, so yours may look something a little bit different to mine, but hopefully not too much. If I go into the stats section and then press dist, now I want to choose this normal thing here because I have a normal curve. And the way to calculate the area under a normal curve is to use this NCD thing in the middle. So I'm going to press F2 there. And then we get this nice little thing here. Now this lower thing here is the point that is at the left end of the area that we want to calculate. So in this case we have 8 there, so I want to put 8 for the lower. Now for the upper, I want to just keep going forever. Well, forever? Yeah, actually I do. I want to go out to the other side of the universe. So fortunately, this normal curve gets so close to this axis, if we go out to the other side of the universe, that the area way out there is just going to be 0. So I can actually calculate this area all the way out to infinity pretty accurately just by putting a really massive number in for my upper. So here I've put 1 times 10 to the 99. Maybe that's a bit of an overkill. Maybe we didn't need that much. But putting something like, I don't know, 1 million in is probably just as good. So I'll tell it that. I also need to tell it what the standard deviation is. It was 2, and the mean was just 6. So if we just press this button now, this button down in the bottom right corner, and press it again, we get that the probability is 0.159 if we round off to 3 significant figures, which is just what I got from looking at this graph there. Now if you are going to use your calculator, quite frankly, I don't know about you, but when I use my calculator, I have a tendency to sometimes press the wrong buttons. So it's a good idea, if you are calculating an area or a probability this way using your calculator, just to write down what it is that you've put in. So here I'll just write that down. So the probability that x is greater than or equal to 8, what that's equal to. So first of all, I'll write down the function on the calculator that I used. So it was this NCD one. So let's put down NCD. Now if we just exit out that, we see that the first thing that we put in was an 8. The second thing we put in was 1 million. The third thing was the standard deviation of 2, and the last thing was just the mean, which was 6. And that also told us 0.159. And that's pretty much it.